residue, by the way, that half lecture, mid lecture, I had to abandon it because I had to quit because internet connection is really fluctuating till now. So, internet connection is fluctuating because of thanks to rainy season, monsoon is coming, so that's why. And that's why I had to leave you mid lecture. I'm really sorry, but I tried to cover it in shorts. I know quality might be different, but sorry. Deepest apologies. So now we are trying evaluate z square by z square minus 1 into z minus 1 whole square, where the mod z minus 1 equal to 1. So this mod z minus 1 equal to 1 is radius. So this you would think that, bro, why it is not complex integral of contour when it is circle, line, or parabola? Why it is Cauchy integral? But because in denominator you won't see this mess in uh, complex integral of contour is a circle, parabola, or straight line. You won't see this weird denominators. Okay, you would see that only in Cauchy integral. So let's try to solve it. First, we have to find points. To find points, we have to take denominator equal to 0. Okay. Okay. Z square minus 1 into z minus 1 whole square equal to 0. But you have to see that we have to reduce things, like reduce powers of these. We have to try that because, see, like we have to break them into factors. Now you can see here, this looks like this. Okay, z square minus 1 looks like z square minus 1 square, because 1 square equal to 1, 1 into anything is 1, so 1 into 1 is also 1, right? So z square equal to 1, z square minus 1, which is z plus 2 into z minus 2. How? By this formula, a square minus b square equal to a plus b minus a plus b into a minus b. You found that, right? Now this would look like this: z plus 1 into z minus 1 into z minus 1 whole square. We can actually break this, but we can't here because this uses different formula here. Okay, now let's uh, put these here. These are in multiplication. Here it will go in division. 0 divided by anything is 0. Z plus 1 equal to 0. Z is equal to minus 1. Then let's do that with z minus 1. With this, these two will divide by 0 is 0. Z equal to plus 1. Minus 1 goes here, plus 1. Okay. Now z equal to 1. Now we got 2 points here. Okay. Wait a second. Yeah, we got 2 points. Now we have to compare it with this. If it was mod z equal to 1, then radius would be directly 1. But now it is mod, inside mod there is z minus 1. Then we have to put our points in this mod in substituting z. Okay, then we have to compare it with 1. So for this it would be 1 equal to 1, 1, while if I put 1 minus 1 is equal to 0, which is inside the curve. Inside, like if 1 is the radius, see, so so we found it is 0. Our point is 0. So if radius is 1, this radius is 1 and our point is 0, so 0 lies here. In a unit radius, in a unit circle, this is radius 1 circle, then a radius touches everywhere equally. Here 1, then here it would go 1, here it would go 1. Only direction would change. Since this is negative side, negative. This also negative. So 0 comes in between, so it is inside. But if I go for z equal to 1, then mod z minus 1 equal to mod Z is equal to 1, right? We put Z is equal to 1 minus 1. Wait a second. Sorry, here Z equal to minus 1, not here. So Z equal to minus 1, no? So Z minus 1 is equal to mod minus 1 is equal to minus 2 or 2, whatever it is. But even if it is 2 or minus 2, it would be outside, okay? This would be outside the circle. So when we have outside the circle, okay, let me show you. So we have to take f of z naught inside, f of point inside, okay, inside is equal to f of z naught by z minus z naught outside in function, right? Because if I take z minus z naught inside, this is opposite of that z naught. Since wait, I would show you. If I take, this is inside, this we have to calculate. If I take 1, let's say 1, so z minus 1, if I take 1 minus 1 will be 0. Then if it is denominator is 0, anything by 0 would be not defined, invalid, infinity. Then how can we solve it? Okay, so we have to take this one, outside one, okay. So we would so our f of z naught in numerator is, but you have to remember that there are formulas, okay. Integration f of z by z minus z naught is equal to 2 pi I f of f raised to here n, then n minus 1 z naught of z naught by n minus 1 whole factorial. So this is the formula of Cauchy integral, okay. Now we have to take outside circle function, because that we can calculate. So here I would take whichever was outside. Which was outside? This is outside, right? So how we found it? Z equal to minus 1, so it was Z plus 1. So we have to put Z plus 1 here and take the numerator, okay. Integration f of z is equal to z square by, oh by the way, here 1, our z naught is 1, okay. Where it is? Z naught, this is Z naught because it is inside. Z naught we point found when taking denominator 0. I forgot to write that. Take denominator equal to 0. Then we took 0, then we found this. Where it is? Yeah, inside 1 point, right. 1 minus 1 0 na. So this point which we found is Z naught. Then we would take its function and z plus 1. So outside whichever was there the factor, we would take that in denominator, like this one, z plus 1, okay. Z square, z plus 1, z square was numerator, so we have to take it. And we would substitute z by 1, okay, the one which was z naught inside 1, okay. Now integration of f is equal to, wait a second, okay, into 2 pi, I forgot, into 2 pi I, okay. 2 pi I 1 square by 1 plus 1 is equal to 2 pi I 1 square is 1 by 2. 2 cancel. Multiplication division opposite same number gets cancelled. Come on, 2 piece of pie, you take 2 piece, then nothing is left. Like you took the whole cake, whole one cake, right? So it is pi I. Simple. Now we would take of z minus 1 whole square. Okay, this is a different thing, so we would do this separately. Okay, so now f of z equal z, since below there is nothing, so we would take 2 pi I f raised to n minus 1 into z naught by n minus 1 factorial. But here it is, yeah, so let me show you once here. Okay, so this is our function right now. Here it in this function it was z square by z square minus 1 into sorry, z plus 1 z minus 1. So this was both linear, right? We read different formula in textbook for this. We read its integration as 2 pi I f of z naught, but it actually comes from this, right? If we take this n as 1, then here 1 minus 1 is 0. This is number of derivative. Okay, derivative, because it is to reduce power. When how much over derivative we take, we reduce power. So this is well, if this is 1, n is 1 here, and 1 minus 1 is 0, so no derivative, f of z not directly, and 1 minus, let n is equal to 1, so 1 minus 1 is 0, 0 factorial is 1, so no derivation f of z naught by 1, 2 pi I is the same thing here, and 2 pi I is same in these both. So this is extra formula to create stress. Don't ignore it. Just only remember this formula, you would easily derive that too. So when we do this, we have first we have to take the denominator, this part of denominator 0, because this is a separate function, right? This is z minus 1 whole square, right, equal to 0. So we take square root on both sides. 0 square root is 0 only. 0, z is equal to 1. So when we take z is equal to 1, right? Wait a second. Oh yeah, we have to compare this too. So now is 1 minus 1 is equal to 0. So 0 is inside the circle. We saw this in previous thing. So in this square term, we don't have any denominator related to that square. Okay, so now we only have to take numerator. Okay, that's why I wrote z numerator. So what we have to take is f of 1, right? We found this. This is inside, so this is z naught. Okay, so f of 1 equal to, so first we have to take 2 pi I f of, so so this is whole bracket raised to 2, right? Whole bracket raised to 2, z minus z naught raised to 2, z naught is 1, so there was z minus 1 whole square, right? So this is z minus z naught, z minus 1 whole square, so n is 2 here, right? So when n is 2 here, we have to take f of 1, right? This was inside z naught, this is, so we have to take f of 1 here, and here it is 2, n is 2, 2 minus 1, it is 1, so we have to take derivative once, by n minus 1, which is 2 minus 1 factorial. Okay, n is 2, no? So at n minus 1, 2 minus 1 whole factorial, 2 pi I f or derivative of 1, because 1 is z naught. So here it is z naught, we put 1, f raised to n minus 1. So f derivative, so f so this is 2 minus 1 is 1 factorial, which is 1, 2 pi I into 0. F of 1 is let me show you, d by dx of constant is always 0. Since 1 is a constant, so its derivative would be 0 to 0. So f dash here means f dash of x equal to d by dx of x, right? So f dash of x means derivative. So here to wait a second. Wait a second. What did I just do? No. It would be derivative of z square, right? So d raised to dx raised to n by dx is equal to nx raised to n minus 1. So since there is no denominator related to whole square, so only numerator we would take. So we take only numerator here. Outside function was not there, so I didn't take anything. And so inside function is substituted here. Inside function, which was z not equal to 1, so that was inside point, we took it. We would substitute this 1 in z naught after it is done derivative. Okay, so now this is 1 factorial, so z square would be nx raised to n minus 1, right? So here n is 2, so 2 n would be outside, 2 nx, x would be z, nx raised to n minus 1, 2 minus 1. Okay, so which would be 1. So raised to is also n minus 1. So here we got 2 into 2 is 4 pi I. 1 factorial is 1, so no need to write, into z, which is our 1, f of 1 equal to so f of z naught, right? F of z naught, so is equal to 4 pi I into 1, which is 4 pi I. Okay, so now we found this one, which is pi I, first one. This is second one. So we found it for both points inside and one point was outside. So integration z square by z square minus 1 into z minus 1 whole square is equal to pi I plus 4 pi I plus 0. So pi I same, 4. So here it is nothing, so 1, because 1 into anything is that only, so here it is 1 naturally, 5 pi I. Okay, this 0 is the outside region, which is z minus 1, and z plus 1 we found it pi I here, and 4 pi I is here, which we found of this square. Then we added them and we got our answer. So thanks for watching. Like, share, subscribe. See you next time. And I'm really sorry I abandoned last midstream because internet was fluctuating, so it was actually a technical glitch. So yeah, bye, see ya next time.